Our last example is one that is an indeterminate form from the caterpillar form that I introduced in the last video. So we have limit as x approaches 0 from the right of sine of x to the x power. So when I initially do the plug-in of 0 and 0 in there, I get 0 over 0, so always plug in to see what we have. And we can see that that's the last indeterminate form on the caterpillar. And again, the caterpillar is tail to the infinity, infinity to the 0, so that's the body part, and then 0 to the 0. The nose and the eyes, or the mouth and the eyes, however you guys want to see it. And so we have this one. And so if you're getting any one of these three forms, what we're going to do is try to rewrite it as a fraction by doing ln and e. So if I'm going to take the ln of something, I'm going to make sure I exponentiate at the end to undo the ln part that I just completed. So I can bring the x down, and I have e to the limit as x approaches 0 from the right of x times ln of sine over x. Well, if I know the ultimate goal is to rewrite this so that it's either 0 over 0 or infinity over infinity, that means that right now at this point I have, actually let's do the plugin so that we can see what we have. So when you guys do the initial plugin, you get 0 and then times, let's think about what it means to have 0 plugged into sine is 0. ln of 0 as it approaches from the right is infinity, or negative infinity. So in theory, you guys have 0 times negative infinity. So that is one of our indeterminate forms as well. So it's not the one that we want, though. We want it as a fraction, either as 0 over 0 or infinity over infinity. So what we do is we take the x that we have here and we bring it down. And the way we bring it down is by making it the reciprocal. So limit as x approaches 0 from the right is ln of sine of x over, if I'm going to move it under, it's going to be 1 over x. And let's always check as you guys go. Plug in 0 and we get, again, ln of sine of x is negative infinity on top. And then 0 at the bottom, 1 over 0 is infinity. So now we have one of our two original indeterminate forms, infinity over infinity or 0 over 0. So we're now going to apply derivatives. So when we do so, we get 1 over sine of x. Mommy function is ln. Baby function is sine, so times cosine of x, all over negative 1 over x squared. At this point, we can simplify things a little bit. You have cosine over sine of x, and then over a negative 1 over x squared. So we can flip our fraction and move it to the top, and we get e limit as x approaches 0 from the right as cosine of x over sine of x, and then negative x squared is on the top once we multiply by the reciprocal at the bottom. So just kind of reducing our fraction down to this. And then from there, if I do my plug-in, I know I get 0 on top, right? I know I get 0 on top because of the x squared. 0 at the bottom is also 0. So 0 over 0 when I do the plug-in. And let me change that to a different color to show that I'm plugging it in. So at that point, I can apply my L'Hopital's rule, product rule at the bottom. Sorry, at the top, limit as x approaches 0 from the right is negative 2x, keep cosine the same, and then minus x squared times the derivative of cosine of x, which is negative sine of x, so plus sine of x, all over the derivative of sine of x, which is cosine of x. So if I plug my 0 in, now always evaluate again, plug in 0, I have that, well, this is 0, plug in 0, this is 0, and then plug in 0. Aha, we don't have 0 at the bottom, which is good. So cosine of x, though, is cosine of 0, which is 1. So at this point, we know we can stop because 0 divided by 1 is 0. So ultimately, our answer is, don't forget about that e to the 0 power, which is 1.